fitness, sports and career activities often involve repeated physical exertion that leads to tendon injury of the ankle, elbow, knee and other joints. Without proper healing, these injuries can turn into a chronic condition called tendinosis. Chronic tendinosis is caused by cycles of tendon injury, incomplete healing, then re-injury, until there are few pain-free periods and the injury enters a degenerative state. Cells which produce type 1 collagen are critical to healing tendon injuries. Often a patient has insufficient collagen-producing cells proximate to the injury to effect complete healing. RepliCel Life Sciences is developing a cell-based platform called RCT01 to address this functional cellular deficit. First, specific collagen-producing cells are isolated from a patient's hair follicles using RepliCel's patented technology. These cells are replicated in a highly controlled process and clean room environment over 4 to 6 weeks, yielding millions of cells. The cells are then injected directly into the patient's damaged tendon using ultrasound imaging. Based on earlier clinical tests, the injected cells are expected to promote complete healing by expressing the proteins needed to restore the tendon's structural integrity, including type 1 collagen fibers, which comprise the bulk of a healthy tendon. The anticipated outcome is the return of a healthy, functioning tendon. RepliCel's RCT platform represents a leading-edge category of treatments which allow a patient's own cells to heal their injuries. Treatments such as those based on RepliCel's RCT platform represent a new class of therapies expected to be widely accessible within a few short years, keeping people active and happy well beyond what current therapies can offer. RepliCel trades in the United States on the OTCQB and in Canada on the TSX Venture Exchange. To learn more, visit us at RepliCel.com. RepliCel Life Sciences, using cells for healing.
Hair loss is a common medical condition that can affect up to 70% of men and 40% of women during the course of their lives. However, an advanced cellular regeneration procedure is being developed to treat this condition. First, a punch biopsy is used to isolate healthy hair follicles from the scalp of a patient. Hair follicles are then dissected, leaving the hair's root. The dermal sheath cup which surrounds the root is inverted to reveal the dermal papilla, which is then discarded. In a growth medium, the isolated dermal sheath cup cells are multiplied to yield millions of new cells. These are then drawn up into a syringe for titrated injection. The syringe is inserted into the upper dermis of the scalp, and the patient's own replicated cells are injected below the skin's epidermal layer. The injected dermal sheath cup cells can migrate to damaged and dormant hair follicles to rejuvenate and further stimulate the growth of hair fibers. The injected dermal sheath cup cells can also induce epidermal cells to cluster, enlarge and multiply to form new hair follicles. As a hair follicle forms, melanin pigment appears within the root. Oil-producing sebocytes develop. These cells divide and grow, giving rise to the sebaceous gland. As the hair follicle reaches maturity, a hair fiber grows and emerges from the skin's surface. The anticipated effect of these processes is to re-establish a full head of hair for patients.